In example 3, we have this scenario. It says a radio station is giving away $1,000 to the first listener who answers the question correctly. If the question goes unanswered for 1 hour, the prize will increase by 10%. That's the key, 10%. It's not going up by the same amount each time. It's going up more each time. So it's going up by 10%. If I look at my ratio here, if I take, since I know it's exponential, if I take 1,100 divided by 1,000, that is 1.1. It's not 10%, it's 110%. Should make sense because 100% would be the same amount each time. If I only did 10%, I'd actually be going down. And notice my y-intercept is 1,000. So when I do my equation, y equals a times b to the x power, I know a is 1,000 because that's where I start at. So it's 1,000 times 1.1 to the x power. X would be the number of hours that you have. I could double check that, take 1,000 times 1.1 to the second power. Let's actually do that. And I've got to get my calculator open. So there we go, sorry, 1,000 times 1.1. We could square that, and notice we get 1210. Exactly what we predicted. This is an example of exponential growth. Example 3 is exponential growth. Now we have a general formula for exponential growth, and it looks like this. Kind of looks the same. Notice it's 1 plus r because we're growing. 1 would be the 100%, and we're going to grow it. So I'm going to write my rate as a decimal. I'm going to change my percent to a decimal. Remember, we moved over 2 places. A is my initial amount, T is my time, and Y is my final amount. So we take a look at example 4. It says the gross domestic product is a monetary value of all the goods and services produced within a country in a specific time period. The GDP per capita is the value divided by the population. So one model says the GDP per capita in the United States was $13,513 in 1946. And it's increased by 2% every year. I want to write an equation to represent that exponential growth. So I'm going to say my final amount, y, equals my initial amount, which that was $13,513. I'm going to take that 1 plus, now I'm going to change my 2% to a decimal. So 2% over here, whoops, I'm going to take 2 divided by 100, right? Percent means per 100, so 0.02. I'm going to raise that to the t power. That's my first sentence there, or my first question. Then I want to find what it's going to be. What's the GDP in 2025? So I'm going to say y equals 13,513 times, I forgot my plus sign there, didn't I? So I'm going to say 1.02. And I'm going to raise that. Well, how many years is it from 1946 to 2025? Well, that's 79. So let's predict. We know it's going to be bigger. 2% isn't that much. But let's look at it exponentially. So let's use our calculator. So I'm going to say 13,513 times 1.02. And we're going to raise that to the 79th power. And notice 64,590.01 if you want to run to the nearest penny. $590.01. And there is your answer there.